Happy that you decided to come and listen to the security assessment, the security vulnerability assessment process, the best practices and the challenges associated with it. The agenda for today, basically, I'm going to give you some. Excuse me.
The mic.
Just have to hold it. Okay. Basically, the agenda for today is that I'll give a little information about myself. Then I'll kind of go through the topic discussion, talk about the actual security assessment process that I follow, and talk about some of the best practices and challenges associated with the security vulnerability assessment, and conclude the presentation. As I stated, my name is Kellep Charles, but most people refer to me as KC. It's a little easier to remember. So feel free to call me KC. I'll also reply to Kellep if you do call me Kellep, so it's no big deal. I'm a government contractor for L3 Stratus in the Washington, D.C. area, and I'm currently at a NASA contract at the Goddard Space Flight Center. I served as an adjunct professor at Capitol College in Laurel, Maryland. There, I was in the computer science as well as the information assurance department, doing teaching classes in information assurance, computer forensics, incident response, and so forth. And currently I'm a doctoral student at Capitol College, and my main research area is in honeypots and using honeypots to analyze detection as well as analyze information in honeypots. And artificial neural networks is the processing engine that I'm kind of using to kind of go through the information. And I also have a very interesting interest in human-computer interaction security, basically just kind of discussing how do we use tools and application in a more enhanced way to enhance the security features, both for security practitioners as well as the common user. And also I operate a website called securityorg.com that just kind of covers various issues in information security, both in the academic side as well as the practitioner side. So that's a little information about myself. Basically, just to kind of give you an introduction to why the security assessment process is important. Working in the federal government and speaking to many security practitioners, we find that understanding the posture of your organization is very important. And this is for a few different reasons. I can remember about 8 years ago when I was working at the Pentagon, about 85% of the computers in our group were the same. The hardware, the operating system. So basically, if something did go wrong, the system administrators and the security administrators were able to kind of pinpoint what needed to be done. But one of the things that I've noticed recently as I go around and do security assessments is that we're finding that there's a much bigger mixture. As you know, Macintosh became a very popular computing environment in recent years, so many users have Mac on their desktop. Also, many of the system administrators who are, boycotting Windows or not feeling Windows, they also have Unix-based systems in their environment. And of course, right now, we're seeing 3 different flavors of Windows. We're seeing Windows XP still in play. Believe it or not, Windows Vista has shown up a couple times. And of course, Windows 7 is a big player right now within computing environments that I go to. So basically, you have a more mixture of different types of operating systems that the security administrator needs to pay attention to. Another thing that we've realized is the applications that we see on the desktops. On an average, we see about 20 to 30 different applications on each desktop. So you're talking about your Internet Explorer, your Firefox, Chrome, you're talking about different mail programs. Some people are running Thunderbird, some people have Outlook, and of course you have your Adobe suites. And another thing that's really interesting is that sometimes someone would go out and buy one of those label maker programs that have these utility programs, and they'll install it and run and run the tasks that they need to do. But what you have to understand, these utility programs, as useful as they are, they normally don't have updates that come out on it. So you have this little utility program to create a label maker, but it sits on your computer for 2 years with no updates. So these are the things that we're seeing as we go around and do our security assessments. Also, distributing computing. Being part of the federal government, one of the big things is telework. So sometimes you have users who are using company or agency provided laptops or using their own laptop to connect back into the information processing systems. So even though you may do everything that you need to do within your internal network, these external networks that are connected also cause some sort of problems that you need to be concerned about. And you also have the internet-facing networks. With the internet-facing networks, you're talking about FTP servers, you're talking about web servers. All of these things add an additional risk to the network that the security assessment process usually brings out and helps. So basically, with all these different things that I talked about, the need to understand the security posture of your organization is very important. And security researchers as well as practitioners have identified that just taking a defensive approach to protecting your network is not good enough. I've been to sites where we conduct a security assessment and a high vulnerability will show up. And the first thing they state is that, well, we have a firewall that protects us from that particular vulnerability. So we all know that, the perimeter defense is a security model, but the security model that the industry practices the defense in depth. So it is important to have a good perimeter security, but, due through technical difficulties, such as firewalls have had issues with vulnerabilities, we find firewalls that had configuration issues. We've had firewalls that had rule sets that allowed certain traffic into the network. So just depending on a firewall alone is something that we do not advise. Another thing is that the firewall and the IDS system is fine. A lot of people put money, time, and resource into the defensive portion, which is the firewall, as well as the detective portion, which is the intrusion detection and the intrusion prevention systems. But at the node level, that doesn't give you any additional information on the posture of your system. And conducting a security assessment kind of helps bridge that gap between what's going on in the perimeter as well as what's going on in the node level. Basically what it does, it just kind of closes that security gap and gives a much smaller security vulnerability footprint if an attacker was to actually get into your system. So another thing about security assessment, as I stated, a lot of people have put time, resource, and money into the detective and the prevention side, and even the response side. A lot of people put a lot of time and money into being able to respond to an incident through an incident response team as well as a forensics team. But security assessment gives you the ability to be proactive about your security, not waiting for something to happen. And some people have even said that it's an offensive posture as well, because you're getting rid of the vulnerabilities before they're discovered in an unfortunate manner. And one of the things that I'll be speaking a lot because of my association with the federal government, another thing is compliance is a big issue when it comes to conducting security assessments. And that's one of the driving forces that makes sure that we go around to the different groups as well as conduct these security assessments on a regular basis. So one thing that I've been able to find as I go around and do security assessments is that we find many systems that are not patched as we conduct our vulnerability scans. And I've come up with 3 reasons why these systems are not patched. The first one is that you have the lazy system administrator. The system administrator does just enough to get the work done and says, well, I'll do this part later, and later never comes. We also notice the overworked system administrator. This is the person that's always being called upon, that's always busy. This is the person that when you go to training and they're coming out of the training class with the phone in their ears, trying to help turn off a fire back at the headquarters. And you also have the misinformed system administrators. These are people who have inherited the job or security is not their main focus. And when you conduct an assessment in their particular location, is that they have no clue about certs, advisories, and so forth. So they're just misinformed, and that's part of the goal of the security assessment, to bring them into the fold. Another thing is that we find that systems are not patched and they get compromised. And the situation is that the compromise that happened on the system, the patch was available. I know a few years ago there was a big thing with like the NIMDA and the Slammer that spread so fast, but the thing is that there were patches available for those systems. And we see that commonly in the field. With my experience in incident response, many times when we responded to incidents, the main cause of the incident is a machine that was the patch that had an available patch. So once we were able to revise the system, bring it back up, we patched it with the patch. We patched the system with the patch that was already available, and we put the system back up. I don't know if anyone saw the H.D. Moore presentation yesterday when he scanned the whole network, and there was about 7 Windows NT systems that was found. It wasn't funny to me because we have 4 Windows NT systems in my location. And the thing is that they haven't been patched in years. And sometimes you run into a situation where custom code is created on a system, and when the developers try to put it on a new operating system, the code crashes. The bean counters get together, they find out it's going to be about $2 million to get this application rewritten. So they go into the process of like, okay, we can't patch the system, let's do a workaround, let's do some firewall rule set, let's put it in a separate network. But these things are the things that you need to know to better understand and protect your network. And again, the security assessment is one of the best ways to be able to find that information. And as I stated, for me, I see the security assessment being a very proactive and offensive ways towards security as compared to just doing a defensive or a responsive posture of waiting for something to happen. And again, it's very vital because of compliance. For anyone who deals with the credit card industry, those who deal with the federal government, come the time when the OAG or the Inspector General comes around, you need to make sure that you've done your due diligence and you've followed the compliance. So when we talk about security assessment levels, the first one is a basic security assessment levels. We mainly use basic security assessments when we have a partner site that might be coming on, but we don't have an interconnection agreement with them. And basically we'll go into the site, we'll look at their physical security, make sure that they have the proper controls to get into the processing lab. We'll also take a look at their technical safeguard to make sure that they have timeouts on their passwords. And just something with physical security is that a lot of people see physical security as not being part of the security assessment process. But as I always state, if somebody has unfettered access into your processing lab and they go in there and add a USB or unplug the system by mistake, that is a security breach. When we talk about physical security, accessibility is one of the tenets of the CIA triad. So if you lose accessibility, that's a vulnerability. So we do check physical security. We check the technical security. We do a question and answer. Just make sure that they're doing the basic security things at their location. We also have an in-depth security assessment. This is where we go in, we do a full scan. We might do multiple scans until we get the systems to a proper level. We do a document review. We look at the firewall rule sets. Being with the federal system, we do a questionnaire off the NIST 800.53 and make sure that they are following many of the regulations. So at the end of an in-depth security assessment, not only do we make sure that they're at least following some of the industry's best practices, we make sure that they're following the FSMA as well as the agency that they're connecting with, that they're following some of those best practices and rules as well. You have the external vulnerability testing. This is something that in the federal agencies, you have agencies where websites for health and financing to do certain things, and basically they just want to see how do they look to the outside world. What services, what protocols are available? Is this something that would be enticing to an attacker? And then you also have the internal vulnerability testing, just to make sure that if someone was to breach your network, that once a worm or a virus hits, it wouldn't spread in 10 seconds. You want to make sure that there's proper segmentation, proper defense in depth controls, that you have firewalls and segmentation to keep the particular worm or virus from spreading around pretty fast. So one of the things is to effectively conduct the security assessment process, you want to make sure that you have a proven methodology. And one of the things about having a proven methodology, both the assessor and the assessee are on the same page. I've seen situations where a security administrator will run a scan and bring a 50-page sheet to the system administrator and say, here, these are your viruses, you need to fix them. And then a month later, they run the same scan and it's 100 sheets. And it becomes a very distrusting environment where the security administrator and the system administrator are at war. I've even seen situations where the management of the security system administrator would talk to the security administrator's team and say, hey, keep these things away from us because there's false positive, these things are not accurate, and the distrust and the program of the security assessment goes down at that particular point. So you want to choose a proven security methodology. Basically, by having it, you have a blueprint of how the process will go from start to finish. And it also is something that could be replicated. So if it's a monthly scan, if it's a quarterly scan, the system administrator group or the group that's being assessed will understand the process each time. It's not something new. It's not something new each time. One of the things that's very important is that the reports from the system, from the security assessments, acts as a short-term blueprint to how your system looks, but more importantly, it acts as a long-term trending report. So if you start off with about 50 highs, and within 6 months, by going through a proven process and you're down to 10 highs after 6 months, this is the kind of things that the COTAR and the CIO likes to see. This is the kind of metrics that you could bring to the meetings to let them know that you are doing advancements, improvements in your security department. And this also allows, again, the agency or the group to understand the vulnerabilities that they have in their particular system. So if something was to come out in an advisory, you'd know like, okay, well, in our last security assessment, this was something that didn't come up, so it's really not a big issue. Or if it is something that is an issue, it'll allow you to act appropriately and real quick. So this is where I go into the security assessment process that I've been using for years now. And basically it just follows about 6 phases. The first one is the pre-assessment process, and from there you go into the in-brief. You have the field work process, you have the report, the out-brief, and the post-security assessment portion. With the pre-security assessment, and this is like one of the most important parts, is where you contact the site that you're going to visit or conduct a security assessment on. This is where stating if it's a letter from the CIO or the COTAR that gives you the approval to go to the site, to connect to their network, and to do any changes that needs to be done. This also gives the site the notice to have their resources ready, because you're going to need either a security engineer with you or a system engineer to kind of help you connect the IP addresses and all the information. So the pre-security assessment is where all the agreement on this information occurs. From there, you have the security assessment in brief. This is where you meet the security group that you're about to assess. It may be local, it may be something that you have to travel to. But basically, once you get there, you meet with all the managers and all the people of interest. You sit down with the network administrators, the management, and you kind of give a blueprint of what's going to happen for the day, or what's going to happen for the time that you're there, such as scans are going to be conducted on this particular day. We're going to do a walkthrough of the processing facility. We're going to do interview questions on this particular day. But this is where the schedule and everything is kind of put into place. As for the field work is where the real work is done. Most of the time when we go into a facility, we do about 2 scans. We do what you call as an initial scan of the network. We get the results. We sit down with the system administrators and go over the results. We give them, depending on the amount of the results, maybe 1 or 2 days to fix the problems. Once the problems is fixed, then we'll do a final scan and take that information. We also run the interview, where we sit with the security team, we sit with the system administrators, we ask them about their contingency plans, we ask them about their processes, we review documentation, and we just kind of do the whole gambit of information at that particular time. From there, we do a report analysis where we take all the information from the scans, the document reviews, the interview questions, we put everything together into what we call a technical report. And I'm not sure if this is easy to see, but this is an example of the technical report. Up here is where, if we have a DMZ and we have an internal network, we'll break those 2 processes out and scan them separately. At the bottom, we would record the final scans. Secure configuration metrics, being in the federal government, all the desktops have to go through a secure configuration. FDCC is one of the things that we use, the federal desktop core configuration, CIS benchmark. All the systems that are on the network should have gone through either the CIS benchmark or the FDCC. We record that information. Depending on the level of the site that we're visiting, if it's low, moderate, or high, certain security requirements are necessary, such as 2-factor authentication, disencryption, on laptops, centralized login, and patch management agents. Again, these are things that we go through and review to make sure that they are in place. And again, this is where the document review occurs, where we have a list of documents from user training records, security assessment plans, network maps, just a whole gamut of things. And first we identify if they've been provided, we've identified if the documents have been signed, and then we'll have any comments stating that maybe that document is out of date or so forth. But this is where we capture all the information. And then we conduct the outbrief. The technical access report and the outbrief document are connected together. And basically at the outbrief, we talk to all interested parties. It's more of an interactive situation where we talked about our findings, we talked about the difficulties in the situation, we talked about any concerns that is done. But at the end of the outbrief, basically the document is signed. We provide the site that's been assessed about 30 days to fix any additional outstanding findings before we mail or provide the documents to the management, both on our side and the other side. And the post-security assessment process, this is a very important part right here. This is what we do once we get back from a security assessment. One of the things with security assessment is that we had one site that every time the scanner would hit port 8080, it would lock up the site and the scanner. So this was something that we were able to identify, put in our post-security assessment process report, and whenever anyone else from another site would, from another team would go out to that particular site, this is information that they would have within the folder. And it's not all technical stuff, it's stuff pertaining to maybe a hotel, the politics associated with the particular site that we were scanning and doing the assessment on. All of that goes into the post-security assessment report, so it's like a knowledge base for the next time. One of the things that we've also realized is that there's been interchangeable use of vulnerability assessment, pen testing, and security audits. And basically, vulnerability assessment is pretty much the process of trying to find all the vulnerabilities within a particular system. Whereas with pen testing, you're mainly just trying to break into the system. So you may only discover one or two vulnerabilities, but you just want to prove that you can break into a system. And with a security audit, it's more of a questionnaire type thing. It's more like you have the NIST 800.53 questionnaires, and you go through the process of asking the questions and making sure that the client or the assessee is within compliance. Another thing that we run into the field is when we conduct a scan, there's this thing called credential scan and uncredential scan. With a credential scan, you're getting into the meat of the system. With an uncredential scan, you're not. One of the examples that I always use is that if you take your car to a mechanic and you ask him to, just take a look at the car, he could open up the hood, listen to how the car is running. He could probably listen to the car misfiring. He could kind of hear that it's idling maybe a little fast and give you an assessment at that particular time. But if you allow him to plug a computer into the car, he'll be able to give you much more information on which coils, which spark plugs are not firing, so he'll be able to give you a lot more information. So with a credential scan, it's pretty much the same thing. And one of the things that we always run into is that we'll have a team who scan their systems before we come, feeling very confident, like, yeah, we've been working on our systems for a whole week. And once we get in there and we do a security assessment, they look at us like, what did you do? Because all this stuff wasn't here before. And we kind of explained to them the importance of credential scanning. So before I came here, I ran a quick little test. As I stated earlier, most systems have anywhere from 20 to 30 applications on it. But this particular test was done with a clean vanilla Windows 7 install. Basically, I did an initial scan without credentials, then I followed up with credentials. So the result was, on the initial scan, there was 0 highs, 0 mediums, 1 low, and 5 informational. And 2 minutes later, when I ran the credential scan, it came up with 7 highs, 8 mediums, 5 lows, and 172 informational. Again, this was a clean install, but if we did have Adobe, Microsoft Office, and a whole bunch of other applications, the numbers would probably be a lot more, both in the uncredential as well as the credential scans. Some of the information that was found within the scan, with the uncredential scan, basically NetBIOS, NBStat, -A was considered a low. Within the informational section, we had a VMware, ESX, GSX server detected. But when you go over into the credential scan, you get information such as administrator user password never expires. That's something that would be very important to know within your processing environment. We have a couple denial of service, remote code execution. So again, the difference between a credential scan and an uncredential scan is very important within conducting the security assessment and the vulnerability assessment process. This slide shows that when a credential scan is performed, it does have to be a little intrusive into the system that the scan is occurring. In the first one, no critical services or anything were accessed, but as you can see in the credential scans, we needed access to the remote registry, the file system, as well as the administrator authentication. As I stated earlier, many of our sites use the FDCC and the various tools to harden the system, but to get access to the right spaces that we need to conduct credential scans, many times certain things have to be rolled back or changed so we could get credentials. And this is one of the political issues that we usually face, where the system administrator will say, hey, we hardened this machine using FDCC and all these things, but for you to conduct a credential scan, you want us to roll it back. And again, that's one of the political things that you need to try to convince them at the end of the day that it's an important thing. I've had many system administrators that ask me, well, why do you need to conduct a credential scan? Because most of the time, when a hacker gets into our system, they don't have the username and password. And sometimes I just have to remind them that, in the past few years, most access to the system had occurred on the application level, such as the Adobe applications and Internet Explorer. So username and password is not always needed to get into the system. One of the things that's very important is to use a vulnerability management process. Sometimes you run into a situation where you may have about 200 findings, and that's something that's not going to be able to get fixed within a week or so. So what we usually do, we usually go for the most critical ones first, and then we'll follow by some of the easier ones and kind of work our way down. So that's something that definitely needs to be put in play when you do a security assessment process. As I stated, compliance is a big thing. So for vulnerability management and vulnerability scanning, PCI, the ISO, the NERC, FISMA, those are very, very dependent on that particular process. And if it's not done, then compliance issues have a chance of causing your team some problems. Other things to consider: when we go to the site and we plan to conduct a scan, we'll notice that a VM player is on the desktop. And basically, they usually say, well, it's a system that we use maybe once or twice a month. We don't want to scan it, but this is a system, a live system that is usable, that can connect to the network. So again, that's one of the political issues that we need to go through to convince them that, hey, we need to do the scan. Another key thing is that in the federal government, and even in the private sector, we've been moving towards cloud computing. And when you're responsible to have regular scanning data available, how do you do that in the cloud computing environment? One of the things that I've noticed that many users have been pushing that particular task on the cloud computing service, where they will conduct the scans and provide it to you on a monthly basis. I've heard various people talk about having certain API plugins to plug into a cloud and conduct the scans themselves, but those are some of the things that you need to consider. I talked about the politics situation. The next thing that I want to jump into is the penetration testing. This is something that we do sometimes because, of course, when you're conducting scans, you have these false positives and false negatives. And all the highs that usually show up, they usually say, well, that's probably a false positive. There's no way that could be in our system. So one of the things that we started doing in recent years is using a tool that has both the vulnerability assessment and a pen testing capability involved. So basically, once you get the results, you're able to flip it and run the pen test in an automated pen testing solution. And sometimes it works and it validates that that particular vulnerability is exploitable, and sometimes it doesn't, but the pen testing is another key way to actually validate some of the findings. I've talked about what the security assessment process can do. This is a little bit what it can't do. It can't find any zero-day malware. It pretty much works like an antivirus system. If it's signature-based, if it's something that's been programmed in, it'll be able to find it. It can't actually conduct the patches for you, so the patching, using a patch management system like Case or a manual process of patching the system is something that you'll have to do. I've heard of a tool called GFI that apparently has a patch management system built in, but I haven't met anyone who's actually had that working, so I'm sticking with it. It can't do the patch. And again, it can't determine between the false positive and the false negative. So that's something through your knowledge, through certain scripts and tools that you would have to go through to kind of validate and verify those when they do come around. So basically, to conclude, the security assessment process, even though it's a very good and proactive process, alone, it doesn't safeguard your system. You need the perimeter defense, you need the detective defense, and even security awareness that we've been able to find plays a big part in the whole posture of protecting your network. At the very least, you want to make sure that you do conduct some sort of security awareness if you are part of like the federal government or a credit card application. It gives you the ability to fix at least the basic problems, as well as shows that you do conduct due diligence, because if something was to happen, at the very least you could show proof that you've done what you needed to do before they come down on you. So that's all I have. I have my Twitter handles up here if anybody would like to keep in contact, and I'll just take some questions at this present time if you have any.
You stated initially that you're utilizing industry best practices, but you only mentioned like NIST and MIDPOM items. Are you doing any SANS elements in there? And you talked about cloud computing, but you didn't indicate any network identification elements that are related to conducting an assessment for a cloud architecture.
Right. As for the SANS, basically, with being in the federal government, we follow the FISMA application to a T. But we do some web scanning, and within the web scanning, we'll follow some other regulations, but basically we pretty much follow the FISMA and all of.
But those are compliance items?
Right.
Which is not security items.
Right. And that's the thing that we usually tell our clients is that compliance doesn't mean that you're secure. Compliance means that you're following a set of a standard, exactly. So in the compliance aspect of things, we stick with the FISMA thing, but when it comes to like the security aspect of things, that's a whole different team and situation that kind of follows through with that. And you're thinking about cloud computing?
Yes. Like you didn't indicate any of the network elements that you were reviewing, any type of, for me, network forensics and the like has become huge because of cloud computing. Things are stored locally, things are pushed up there, so you actually have to monitor multiple traffic streams and find out what is going on in the storage space, whether it's storage as a service or infrastructure as a service, whatever the cloud type is. So, how are you doing? Because that was, I didn't get the explanation.
Right. Well, basically, I looked at it from this particular point is that to be compliant within FISMA compliant is that you have to show that you're doing regular security assessments, that these systems are constantly going through. So basically, where we would run security assessments, collect the reports, and patch the machines, the provider is actually doing the security assessments, providing us the report on the status of the application.
That's the self-assessment checklist.
Exactly.
Okay.
How do you handle false positives that from say, like your antivirus is going to create some false positives? Typically, you should do some sort of workaround to make sure that doesn't interfere. Do you keep that in your notes? Do you rescan?
Yeah, some sites, as every time you do a particular scan, maybe that same false positive might show up. So once we're identify that if it's a false positive or false negative, that's something that goes in the report. But to actually test it out, again, we have like a utility tool that comes with the scan-in that it checks against that vulnerability 3 times to see if it's exploitable. We also employed the penetration testing tool, which is an automated tool, and again, it checks to see if it's a false positive or false negative, and we record everything, not only in the action report, but as well as in the outbrief. So 6 months later or a year later when you come and that same vulnerability show up on the systems, at least you have a head start to know that, okay, this was something that we saw last time, and it was validated that it was a false positive or false negative.
What's the answer for Java?
Well, my answer is like, don't run it, just try to turn it off. But in reality, it's one of those things that come up, and we have something that's called a waiver process. So if Java is needed to perform a particular task and it's unable to be fixed, we have something that's called a waiver process where they would waive it, and that actually moves the risk from our shop over to their shop that they decided to run it.
What are the tools on people's desktops that they need for their interoperability with other researchers in the academic environment, but that's like not like Dropbox and a bunch of what do you do with software like that when you do a vulnerability assessment? What's your recommendation?
Well, I mean, again, if you're connecting back to the main agency, and the agency policy said, this is something that is inappropriate, unless there's a strong justification stating that this is needed for a particular mission and there's no other alternative, we might recommend something else. But again, there's this thing called a waiver process that if there's no other way to get around it, that's waived. And if something does happen with that, it doesn't fall in our lap, it falls on your lap.
Do you remember the name of the software that you were referring to with the vulnerability and the pen test?
Okay, I wasn't trying to do any product plug-in, but Saint was the one that does both. Saint, SAINT, it does both the vulnerability and the penetration testing. Basically, it takes the results from the vulnerability scanning, then you could hit a button and it'll show you the same result, and you could pen test the findings. All right, thank you everyone, and I'll see you around.
That's